I'm recording. Record the entire screen. Share. Okay, here we go. All right. Okay, so we're going to talk about 8.2. And then tomorrow won't be a crazy day because it's the day before Thanksgiving vacation. I usually don't do much before that anyway, even during normal school times. So, and today's homework is on delta math. So hopefully if we have time, maybe you guys can give me your 2 cents what you thought of delta math yesterday. I heard some people were unable to sign in for my first class, so maybe you could tell me about that. Tell me what your experience was. And let me know if you want to do it again when we get back. So anyway, 8.2, angles and radians measure. Angles and radian measures. Radians, let me pluralize that if I'm doing angles and radians measure. Should be, well, okay. So draw this coordinate plane. And you know how we have here, like I drew, hopefully you can see how it's purple here. And I drew an angle. Okay. And this angle I listed as 140 degrees. Okay, so go ahead and draw that. We have a couple things we're going to use to help us talk about these angles and how we identify what's what and how we measure them and stuff like that as you guys are drawing that out. So this angle starts here on the, we'll call this the positive x-axis, because in this direction it's positive, this direction it's negative. This would be the negative x-axis. This would be the positive y-axis. This would be the negative y-axis. Okay. So this is the positive x-axis right here. Where I start my angle, of course, we call these sides rays, but this ray, for this angle that's on the positive x-axis, we call that the initial side. So write that down. That's the initial side. And then as we open up, we have our second ray of the angle. We call that the terminal side. So we have the initial side all the way to the terminal side. Okay? Okay. Now that you see that, we're going to go on to something else. Are there any questions on that, the initial side and the terminal side? I'm going to get rid of this picture in 10 seconds. Okay. Now, if you see this as a spin, right? I spin, this can keep going around, all the way around, all the way around, all the way around to 360 degrees. But then it could keep going around, keep going, and we can keep, imagine if this was like a clock dial and it just keeps spinning. We can keep spinning it and spinning it and spinning it, and we'd keep having those degrees. Now, imagine this. Let's draw this here. Draw a picture of this. We're going to call coterminal angles is the new thing that we talk about here. Okay? So draw our coordinate plane. This is the x-axis. This is the y-axis. Now, draw this angle right here. Do it in purple. But watch how I draw this angle. Let's spin the angle. Go to this 140, and we're going to keep going, keep the angle going until it stops again right there in that same spot at 140 degrees. Can anyone tell me how many degrees that angle is now? Anyone have any idea?
Is it 500?
Yes. Did I have it on there? Yes, you're right. It's 500 degrees. Does anyone know why it's 500?
140 plus 360.
Very good. 140 plus 360. Okay, cool. You get it. So anyway, there are two angles there. So you can imagine that there are two angles here. There's the 140-degree angle, and then I had here, I guess maybe you guys saw it was the 500-degree angle. Because you go 140, and then you go 360 degrees again, and you hit the 500. There's two angles. We call those angles coterminal angles. And there's another. I can go again another 360, and then that would be 860 degrees, right? There's another angle there. You spin again, and then you spin again, and you have 860 degrees. So to figure out coterminal angles is you just either add or subtract 360 degrees to your initial angle. Like, for example, what are the coterminal angles of 240 degrees? So let's say here, I'm sorry, can I remove that? I'm gonna remove this in 10 seconds unless someone needs it. So let's say I have I'll say the question will be, like, what are the coterminal angles of 240 degrees? Okay. Well, 240 degrees. Now, you don't need to draw this, but I'm going to draw it so that you can figure out how we get that answer. Is all you have to do, let's figure out where 240 is. Okay, so where's 240? This is my x-axis and my y-axis. Well, I know if I go from here to here, that's 180. And then to add another 60 degrees is going to be 240. So 240 will be over here. By the way, so that'll be 240 degrees. By the way, I have a joke. Why are there only 239 beans in Irish stew? 239. Why are there only 239 beans in Irish stew?
Why?
239 beans. Why are there 239? Because if they put in one more, it'd be too farty. Too farty. Too farty. You can tell anyone that as your joke. Too farty. Anyway, whatever. Sorry. I always thought that was a good one. So anyway, 240 degrees. What is a coterminal angle? Well, my coterminal angle will be here, and then you go another 360 degrees, and so you just add 240 plus 360, right? And that would be 600 degrees. Those would be, so coterminal angles would be 240 degrees plus, and 600 degrees. Those are coterminal angles because you have one here and one there. There's two angles right there. And you can add another 360, and you can say, hey, 960 degrees is another coterminal angle. You can spin around again. And guess what? We can spin backwards from here and go 240 minus 360. And guess what will be in the negatives? Where's my calculator? 240 minus 360. 240 minus 360. And it's negative 120. So another one, coterminal angle, is a negative 120 degrees. That's if we went backwards. Let's see if I can draw this. Negative 120 is if I start here and I go this way. Well, guess what? That'll be negative 120. Negative 120 degrees. Okay, so those are coterminal angles. You can go backwards. So anytime you want to find, hey, so what are coterminal to 50 degrees, right? Well, you just add 360 to it. You know what's coterminal to it? 50 plus 360. And you say 410. Or you can take away 360. 50, take away 360. I'm going to get rid of my glare here in just a second. And you get negative 310. Okay, those are all coterminal. You just add or subtract 360 degrees. Anyway, that's my thing on coterminal real quick because I was short for time. Are there any questions on coterminal angles? Coterminal? Try to get that little glare out of the way. All right. Okay, fine. That's the first lesson, coterminal angles. Now let's talk about radians, okay? So real quick on radians, let's first talk about the circumference of a circle. The circumference of, you know, Thanksgiving is in 1 week exactly. I gotta buy my turkey. Do you guys remember how to find the circumference of a circle? I feel like I should call on someone. Circumference of a circle. Brandon, you know, find the circumference of a circle?
No,
Do you know what a circumference of a circle is, Brandon?
I don't remember.
Okay, let's see. How about you, Carlos?
I don't remember either, but is it the radius?
That's part of a circle, but hey, I like how you're using circle terms. The radius is in the center to the end. Gianna, do you remember how to find the circumference? Do you remember how to solve for the circumference of the angle?
Is it 2 times pi times the radius?
Yes, awesome. That's very strong. Strong work. Okay, everyone write this down. Circumference is 2 times pi times the radius. Now, my other question is what the heck is a circumference? What the heck is that thing? Jaylene, what's a circumference? What is it? Jaylene?
Isn't it just like the outside of the circle?
Yes, it's the distance around the outside of the circle. How far around is that? Now, let's say our radius is 3 inches. Okay? Let's solve for the circumference. This is my radius. The radius is the center to the end, right? The circumference is going to be 2 times pi times 3. Okay, in terms of pi, can anyone tell me what the circumference of this circle is? Joshua, go for it, man. What's the circumference?
Well, I'm still working on it.
No, dude, stop. You should be able to do this in your head. Let me ask you something, Joshua.
Yeah.
What's 3 times 2?
6.
Pi. Very good, Joshua.
Oh, okay.
The answer is 6 pi inches. That's all you have to do. That's all we need to do for this. Okay, everyone understand that? See, Joshua, it's easier than you thought, right?
Yeah.
Okay. Now, another thing before we talk about radians. First, you understand how to solve for the circumference of the circle. Now, before we talk about radians, let's ask a simple question. How many inches are in 2 feet? Okay, Kayla. How many inches are in 2 feet?
24.
Very good. Kayla,
Yes.
Which one's longer? 2 feet or 24 inches?
They're the same.
No, 24 is longer because it's bigger, right?
No.
I know you're with me, Morella, right? Give me some support here, Morella. 24 is bigger than 2, so 24 inches is bigger than 2 feet, right, Morella?
It's the same length because the 1 foot is 12 inches. It's just
What are you guys trying to do to me here? Yes, you guys are right. They are the same because inches are smaller than feet. It takes 24 inches equal 2 feet. The point being, they are the same. We're just looking at different units of measure. This one is inches and this one is feet. Now let's talk about a radian. A radian, okay, so we talked about the circumference of the circle, talked about feet and inches. Now we're going to talk about radians. A radian is how we measure an angle. Just like what feet are to inches, radians can be converted to degrees. And degrees can be converted into radians, right? If you look at your calculator, let me zoom in real quick. Oh, it just turned off right when I... Now you see here, see the little DEG? That means my calculator is calculating everything in degrees. But I have this little button here that has DRG on it. If I hit it once, it goes to the R, which, see, I can go to, let's see, how does this work? I can go now to, whoops, can you see that? Radians. So radians is a measure that we use. Now, the question is, whoops, let's get smaller. Unnecessary zoom. Just like we have 12 inches in 1 foot, how many degrees are in a radian? Well, let's talk about what a radian is. Okay? So radian can be in degrees. So let's go back to our circle. Okay. Now to go all the way around a circle is 360 degrees, right? 360 degrees. Now let's say that that radius is 1, just 1, not 1 feet, not 1, it's just 1. Let's say it's 1 whatever. What is the circumference of that circle if the radius is 1? What is the circumference of that circle? Let's go with Madison.
I'm not sure.
What part are you stuck at, Madison?
Trying to figure out what the circumference, or no. Yeah, what the circumference is.
Well, what's my radius here, Madison?
1.
And so what do I put in for R?
1.
Yeah, good. What's 2 times 1?
2.
2 pi.
So you always put 2 for the pi?
The circumference of a circle is 2 times pi times the radius.
Okay.
That's the formula we use. Okay. So when you plug it in, so all the way around here, if my radius is 1, all the way around the circle is 2 pi. And also all the way around the circle is 360 degrees. So what we can say is all the way around the circle is 360 degrees is equal to all the way around the circle is also 2 pi. Now this side is going to be degrees. This side is going to be my radians. And let's just get rid of this 2 by dividing both sides by 2. And 360 divided by 2 is 180 degrees. 2 divided by 2 is pi. So guess what? 180 degrees is equal to pi radians. So write that down. That's after all that, if you didn't understand what I said, all you have to know is that 180 degrees is equal to pi radians. Or 180 degrees is equal to 3.14 radians. Now, we're almost done here. So how do we convert degrees into radians or radians into degrees? You're going to use a conversion factor. Conversion factor. You're probably using these conversion factors in chemistry. I love chemistry. The conversion factor degrees to the radians. So go from degrees to radians is pi over 180 degrees. To go from radians to degrees, we're going to do 180 degrees over pi. So let me reiterate that. If I want to convert degrees into radians, I multiply by pi over 180. If I want to go from radians to degrees, I multiply by 180 divided by pi. So guess what? Let's do one. I'm going to get rid of this. Are there any questions on that? Okay, so moving on then.
Quick
Here's
question.
how yeah,
Is that
what's
dot
up?
a bullet point or multiplication?
Multiplication.
Okay.
Show that's times. Good question. I was trying to make it times. Thank you for asking that, Kayla. So let's say I want to convert 120 degrees into radians. Well, here's how I remember. I don't think about this. I think about, hey, if I want to change it to radians, I put the radians in the numerator. I put the radians on top, and then you just multiply them. And then you make it into a fraction. The reason why, notice how the degrees are on the denominator. Look at what happens. Watch 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 what happens. Flink, flink. The degrees cancel out. They disappear. Sorry, get out of there. And so my answer is going to be, watch, 120 times pi is 120 pi over 180. And then we just simplify. I'm going to simplify it. Simplify my answer. The zeros cancel out. 12 pi over 18. Both of these are divisible by 2, or not 2. Divisible by, well, they're divisible by 2, but they're also divisible by 6. So it's 2 pi over 3. So guess what? 120 degrees is equal to 2 pi over 3 radians. Just like 2 feet is equal to 24 inches, 120 degrees is equal to 2 pi over 3 radians. And in radians, we don't have to write the word radians. As long as we see that pi there, we're good. How are you doing on time? Should I do another one, or should I go from radians to degrees?
Radians to degrees.
All right. Anyone want me to do another one? Because I don't want to. You know, we have a next 4th period class coming up after this because I started late. Let's go radians to degrees. Let's have pi over 12 radians, and I want to convert that to degrees. Well, I want it to be degrees, so I put the degrees on the top and the radians on the bottom. And all you got to do is
Is that a negative pi?
Yeah, it's negative.
Okay.
Weird, huh? That just means we go backwards, right? We go in this, like if we had our unit circle, we're going in this direction. Sorry, that's an ugly arrow. So watch what happens. You cross out the pi's, right? Because those cancel out. And it's equal to negative 180 degrees divided by 12. What is 180 divided by 12? Calculate it out. Make sure you have that negative there. I'm going to call on one of you. Be ready to calculate it. All right, Taylor, what'd you get?
Negative 15 degrees.
Very good. Just do 180 divided by 12, negative 15 degrees. So negative pi over 12 radians is equal to negative 15 degrees. All right. Are there any questions? I did that quick. I'm sorry, but I wish I did it. I wish I started class on time. But I did it. But we got it done. You guys seem pretty stressed about the delta math. Was it as stressful as you thought, or was it? Speak up. Yes, Ariana. Look, you want to say something?
Yeah. I just didn't like how once we got it wrong twice, like we couldn't like redo our mistake. Unlike how if we do it on like our paper, like how we regularly would do it,
I'm sure I can fix that. I'll try to fix it so it doesn't do that.
And then like on here, like regularly, like we would just be able to check the answers, and then we get to figure out and then read the directions again and be like, oh, so that's how you do it, and then get the answer it's supposed to be. You know? So we have multiple tries to do it on our own.
Wait, say that again. Sorry, because someone clicked on. I had to click on something that a message came up. So
just that it only let me try twice. Unlike if we did it regularly, I could try multiple times until I got the answer that the.
Well, let me try. I'll try to fix that. See if I can. I'm sure I can.
Okay. And also, I felt
I actually
weird.
like.
Oh.
Wait, sorry.
My bad.
I actually like delta math because it just saves time because you could just check examples and videos on the same page. You don't need to go in between modules all the time.
Okay. Well, yeah, that's what I was hoping for. And if I can fix that thing for you, Ariana, maybe you'll like it more. But do it tonight. Was anyone? How about this? You guys can go if you want right now. If you want to talk about delta math, you can. If you want to need to do a couple more examples, you can stay. But we have fourth period coming up. So if you want to go, you can. Otherwise, you go ahead and stay. I'll see you tomorrow. You want to talk about delta math, or if you want to do any more problems. Okay, see you guys. Bye. Let's see. I don't even know who's leaving. Bye, John. Bye, Ariana. Bye, Roberto. Bye, Jacob. Bye, Brandon. Okay. Oh, well, that was easy.